Good afternoon, everyone. It is my great pleasure to introduce our esteemed guest for this afternoon session, Mr. P. Arun Kumar, engineer and trainer from MCOT Solutions, Chennai. Mr. Arun Kumar is a passionate electrical trainer and career coach with over a decade of experience in training students and professionals with a strong focus on electric vehicle technologies and skill development. He is a mechanical engineering graduate, holds an international diploma in business administration, and has completed a professional diploma in aptitude and mental ability. His core expertise lies in electric vehicle training, where he actively works on EV awareness, emerging EV technologies, and practical aspects of EV systems, including EV charging infrastructure. Alongside this, he has trained more than 10,000 students and over 2,500 working and government professionals, bridging the gap between theory, industry requirements, and real-world applications. He has been recognized by several reputed institutions for his contribution to technical education, and he was honored with the Young Education Icon Award 2018 for his impactful mentoring and training initiatives. We are delighted to have him with us today as he shares his insights on electric vehicle charging infrastructure, a topic of growing importance in today's sustainable mobility ecosystem. Please join me in giving a warm welcome to Mr. P. Welcome, sir.
Thank you, sir, for the clear and informative introduction of our distinguished guest. Now, it's my great pleasure to invite Mr. Arun Kumar to kindly take over the session and enlighten with us.
Right. Good. So, charging infrastructure, right? நம்மளாமே பேசிக்கா நினைச்சிட்டு போறீங்களா? இது எலக்ட்ரிக் வெஹிக்கிள்ஸ் வந்து ஏதோ இப்போ ஸ்டார்ட் ஆன மாதிரி ஒரு சிம்பிளான சில விஷயங்கள்லாம் வந்து ஞாபகம் இருக்கும். லாஸ்ட் ஒரு 10-15 இயர்ஸ், லாஸ்ட் 2 decades, ரைட்? லாஸ்ட் 2 decades எலக்ட்ரிக் வெஹிக்கிள் அப்படிங்கிறது வந்து ரொம்ப பூஸ்ட் ஆகுற மாதிரி ஒரு டெக்னாலஜி. Blunt English, right? Good. Right? We thought started at least 15 years or 20 years back or 2 decades back on the electric vehicle technology, but it's not like that, right? So both are contemporary. IC engines and electric vehicles, both are. But the issue is only 2 things with the electric vehicles. With electric vehicles, only 2 things, right? The first one is the range. That is distance covered per charge. First thing is range, the distance covered per charge, right? And the second one is recharging options. And the second one is recharging options and secondary batteries. The issue with secondary batteries, we can divide batteries into 2 groups, right? Majorly primary batteries and secondary batteries. So primary batteries, that is non-rechargeable type, and secondary batteries, that is rechargeable type, right? So that is the issue, only 2 issue. So immediately what they decided means the type, that is IR1, right? Industrial Revolution 1. Industrial Revolution majority, and basically it's completely depends upon the water, that is the source of steam energy. The source of steam energy, right? Industrial Revolution 1.0. Now it's going Industrial Revolution 4.0, right? So Industrial Revolution 1.0. So that is what the issue means, the charging infrastructure developments and range. Those are the 2 major issues with electric vehicles for transportation and other things, right? So that's why what they have decided means for 2 things. They split the purpose into 2 types, right? So for transportation, for movement, for continuous movement, what they have decided means they have decided to use IC vehicles, internal combustion vehicles, and for stationary things, right? That is fixed in one place and particular place. There is no requirement to move that things and all machineries and all to the other place, or frequently something like that means what they have decided. They have decided to use electrical machines, right? Electrical machines. So nowadays also you can see a lot of industries are there. You can find it out some hundreds of years old electrical machines, particularly electric motors, right? So they decided once in transport or in movement means we have to use the IC vehicles, right? And fixed means we have to use the electrical machines, particularly electric motors. So that is the decision. But after the invention of lithium, after the invention of lithium in the late 1980s, after the invention of lithium, and the thing is changed again, and we are much more concentrated to a particular thing, that is global warming. Global warming. So they are exploring continuously other options to fight the global warming things and the issue with electric vehicles, that is range and charging problems. They decided to sort it out, and each and every government, international organizations, national organizations, everything, each and everything, they transfer just their views towards electric vehicles, right? And our Indian government also introduced two policies, right? FAME 1 and FAME 2. FAME 1 and FAME 2, right? Fast adoption and manufacturing of electric vehicles. That is FAME 1 and FAME 2 policies to increase the production and to convert and to guide or to divert our things, our thoughts, everything towards the IC engines only, right? So they decided to just divert the thing towards electric vehicles. So for that the government not usually, each and every time they will use one particular thing, kind of things, right? That is that is especially some kind of thing. Whenever the economy goes and they travel in a particular direction means the government has decided to convert into the other side means they will introduce some kind of things. One of the famous very thing is that is subsidy. That is subsidy. 10% subsidy or 20% subsidy or 30% subsidy, and second one is tax exemption. And second one is tax exemption, right? And now for slow vehicles, that is your vehicle, your electric vehicle, particularly electric vehicle, two-wheeler scooters means its speed is under 30 kilometers per hour means there is no registration process and there is no limitation and rules for the driver also. The rider also, right? So there is no requirement for driving license on that because it's a slow moving vehicle. So there is no impact in case of anything happen, any accidents or something happen means no issue with it because it's a slow moving vehicles. So that is the guidelines, and again lot of subsidies. And if you are going to invest in electric vehicle field means they are encouraging you, right, to invest in that particular field. So they are diverting like that. Simply government around 60, everyone, you have to buy electric vehicle. We should not buy IC engine like that. They won't implement like that, right? Or otherwise we can't listen to those kind of things, right? If you are doing like this means I'll give you this, right? Like training a dog or pet animals, right? If you are doing like this means I'll give you a chocolate or I'll give you a snack, something like that means. So they will transfer the things, right? So subsidy, tax, lot of things are there. So we are taking a positive way only. So try to convert or divert our views towards electric vehicle technology after the invention of lithium. What is the difference between innovation, invention and discovery? Anyone? What's the difference between innovation and invention? Yes. Yeah. Inventing something new, it's not there in history, in the past. Then what is innovation?
Adding something to the existing one.
Oh. Actually you are right, but you are opposite. Right? Innovation is the first definition, which is not there in the past. Now only you are going to find out to find something for the first time. For the first time means that is called innovation. And then you are making some developments in that means that is called invention. So electric vehicle field, that is invention. Lot of inventions are involved over last or past 2 decades. That is after 1980s. Right? After 1980s, right? So inventions means there is a so first In very first thing, we are finding something like that, right? The television means that is innovation. The technology with the CRT, right? Cathode ray tube, right? And then we developed something like that, right? Some of the developments from CRT to LCD and LCD to LED and the LED to OLED, curved LED, right? Slim LED, right? So these are things of invention. And what is about discovery? So you saw one place, right? Almost in our school days and most of the times Columbus discovered America. Columbus discovered America. It's there, but no one aware about that, right? There is one continent, that is, there is one land surface, something like that. The first person, Columbus only introduced to the world. This is another land surface, this is the continent, and this is the kind of things and all, right? So it's there, but no one aware about that, existing the same kind of things, right? So that is called discovered. And again, same thing happened with lithium also, right? So they discovered the lithium, and they trying to use and they trying to improve the two major disadvantages of electric vehicle. Two major disadvantages of electric vehicle. One is range, and the second one is charging issues, right? That is high energy chemical composition, high energy density chemical composition, right? So lithium, with lithium, a lot of chemical compositions are there, right? In modern commercial vehicle or electric vehicle battery pack, we are using number of various chemical compositions with lithium. Yesterday also I think we studied this, right? IFR, ICR, IMR, INR, right? Lithium manganese, lithium cobalt, lithium nickel cobalt manganese oxide, lithium. IFR is very important, right? Lithium ferrophosphate, LiFePO4, right? So this is the thing, and now we are going to study about the charging infrastructures development in India particularly. That's why we are using the document. And first one, our first topic, characteristics of EV supply equipment, right? EVSCE, electric vehicle supply equipment. In simple term, we can call it as charger. In simple term, we can call it as a charger, or electric vehicle power supply equipment, or electric vehicle charging equipment, right? Electric vehicle charging equipment, that's the first thing. And see the categories of that. For electric vehicle two-wheeler, for electric vehicle two-wheeler, the battery capacity maximum 1.2 to 3.3 kilowatt hour. Maximum for two-wheelers 1.32 to 3.3 kilowatt hour, and battery voltage. Yesterday also we discussed, right? 48 to 72 volt. 48 to 72 volt. And see the things. Last one. And see the higher capacity things. 350 to 500 volt. Tesla BOID AC motors, right? They are using the same kind of things. That is fast charging kind of things. Everything. Ultra fast charger. Ultra fast charger will take almost maximum 30 minutes for a complete charge. Maximum 30 minutes. Some of the vehicles are on the road, right? You might have seen that. That is the Nebo, and a lot of electric vehicle bus operators also there in Chennai itself, right? So they are operating buses from Chennai to Bangalore and Chennai to Madurai, and some of the important lines, right? So they will take around 45 to 1 hour for complete charging again. So if you are spending 1 hour in between your travel time, it will get confused, right? Why I have to choose electric vehicle buses? I am wasting 1 hour here in between some areas, right? So that is the issue. So in commercial things, they can adapt the ultra fast or super fast chargers. Ultra fast or super fast chargers, that is charging system we can study 3.0, 2.0, 1.0 kind of things we will study later, right? So one by one, and see the things. and other things. That is 3-wheeler means 3.6 to 8 kilowatt hour. To increase the range, it requires more energy, right? So that's why its capacity is high. And see the electric cars. Electric cars actually 21 kilowatt hour, and see the battery pack capacity, battery pack voltage 72 volt. 72 volt. See the 72 volt, 110 volt. These are very low model and low range of vehicles in electric vehicle, right? That means in 4-wheeler segment, right? And see the next one, that is very important. See the green color one, mode 4. See the one, mode 4, that is electric vehicle power supply equipment. That is electric vehicle power supply equipment. See the things, and for 2-wheelers, that is 48 to 72 volt only battery capacity. So we can use our homemade voltage source, that is AC points. Our home based AC points itself we can charge it, right? And another kind of varieties of chargers also available there in India. Particularly, the latest one is battery swapping technology. Battery swapping technology. For IC vehicles, it will take around 2 minutes, right, to refill the fuel tank and all everything. For 2-wheelers, it will take around only 1 minute, something like that. And for 4-wheelers, it will take a maximum 5 minutes to fill the tank again, right? IC vehicles. But in electric vehicles, at least in ultra fast charger also, charging technology 3.0 also, it will take 30 minutes to complete the SOC, to reach the SOC from 0% to 100%. From 0% to 100%, right? So that is the thing. And since the power supply equipment and model 4, that is DC charger. Electric vehicle power supply equipment is basically operates in DC voltage, high voltage. That's why it's a fast charger. We can call it as in another term, fast charger. Fast charger in itself, that is a DC charger. It's not a AC charger. It's not a alternate current charger, right? It's a only DC charger. So DC charger, fast charging means it's simply DC charging. So we have to connect our electric vehicle power supply equipment with high voltage grid. High voltage grid. We can't find it out at regular intervals, right? High voltage passing lines. High voltage grid means somewhere only it will be available. Somewhere, right? But not actually. If I am looking for every 10 kilometers or 20 kilometers of heavy voltage passing grid line means no, it's not possible. I can find it out around 150 to 200 kilometers. Once and every 150 to 200 kilometers. That is the issue. So implementing fast chargers, DC chargers in very frequent manner means so it's not possible right now. With the existing infrastructure technologies, we can't implement it like that, right? And see the next one. Next thing, directly the electric vehicle power supply equipment is directly connected to the battery. Electric vehicle power supply equipment is directly connected to the battery, right? See, there is any equipment? No, nothing is there, right? From a power supply equipment to directly or battery pack through BMS. Because we can't bypass BMS, right? The charging and discharging, everything. Charging and discharging, both the things we can do after the BMS instructions and all, right? So, from power supply equipment to directly BMS and BMS to battery pack. BMS to battery pack. But on the other side, see on the other side, that is AC charging stations, right? So first we have to use that AC, and AC we have to convert that AC current into DC, right? By using rectifier. By using rectifiers, full bridge rectifier, right? Full bridge rectifier. So we have to convert that into full bridge rectifier into DC, and then DC to again we have to filter by using some kind of capacitors or something like that. We have to filter the noise and everything, right? So again we have to convert that DC into AC. DC into AC because to increase it into high frequency alternating current, HFAC. High frequency alternate current, right? Again, because transformer will work in only in AC, right? It will not work in DC. because frequently it has to release the energy. It has to frequently absorb the energy and it has to frequently release the energy. No, transformer will not do that. That's why we are focusing and we are using the other components, converters. Things are converters, right? Boost converters, buck converters, and all, right? So because the problem with the transformers will work on AC, right? Will not work at DC. So we have to convert that DC into AC again, and AC that we have to convert it into higher frequency, and then again by using again one more full bridge rectifier. Again we have to convert that AC into DC, and again one more filter, that is capacitor, and then only battery pack. Right? But on the see the next one, the electric vehicle power supply equipment, that is completely operates on a high frequency, higher current, that is directly DC, higher voltage grid lines. So no need to convert that into things and all. So we need one special equipment. See the thing, that is on-board charger. What is it? On-board charger. So on-board charger only will convert the AC into DC and filter the things, and it will convert it into again AC, and then again high frequency AC, and then high frequency AC to DC and battery pack. And it will supply it into battery pack. So these kind of things we have, we can't take that components, all the components, right? That the full bridge rectifier, infrastructure, and everything with along with our charger. So that's why they will split the charger into two parts. One is called on-board charger and the other part is off-board charger. One is on-board charger and the other part is off-board charger. Off-board charger means only the plug, the cable and things will be there, right? But in on-board charger, all the other components, that is which is converting AC into DC and filtering components and again high frequency converting components, everything will be there in the on-board charger. So you have to be careful. It's not like that, right? Like our mobile phone. It's simply one power plug and simply connecting that cable to the both charging port in our mobile phone, right? So it's not like that, right? So you have to be very careful, and there will be two ports in your vehicle. So one side is, that is fast charging provision, that is for DC, and one side, that is AC. So because after AC power supply from homemade plug, and then it will go to the onboard charger, it will do all the things, all the converting things, all the filter things, everything, onboard charger, and then it will convert into high voltage DC current, then through BMS, then battery pack. Through BMS, then battery pack. So now you understood the things, right? What is onboard charger? What is off-board charger? What is onboard charger? What is off-board charger? And another majority of types will be there, right? Simply it's a charger, only connection will be there, right? That is, it will connect the current from the power source to battery pack. Simple. There will be no communication. It's continuously getting charged again and again after reaching 100% also. The charger will supply the current, right? So we have to be very, very careful. But nowadays, what happens with your mobile phone? See the latest technology mobile phones, after 100%, it will automatically cut your charging circuit to avoid the overheating of cells. Right? So otherwise, lithium ion cells is very major disadvantage is that, right, for lithium ion cells. Lithium ion cell has higher energy density and comparatively with lithium ferrophosphate, right? Because lithium ferrophosphate, the higher cutoff is 3.33 volt, but for lithium ion that is 3.65 volt. So energy density is high, but the problem with lithium ion cells is there is one more concept that is called thermodynamic things. So after reaching the full SOC, full percentage of SOC, that is 100%, and again it supplying current means it will increase the temperature of the cells, right? So then the temperature of the battery pack will increase and it will lead to some kind of accidents, battery fire or battery blasting, something like that, right? So you have to be careful. So once it's 100%, then at least we have to make some communication between the charger and the battery pack. CAN. CAN, right? Control area network things. So most of the chargers in higher voltage operating vehicles, that is higher head models, it has automatically the things they will include the provision of CAN things and all. So it will communicate. They communicate between the point and the current source and the battery pack. So two-way, right? You will see it later. And any doubts? This one. And see the charging port types. Charging port types. There is difference, right? Because we don't know. Each and every time we have to be careful about the port, right? We are connecting the AC current source or DC current source. Each and every time we have to check, right? So in petrol vehicle also the same thing I have learned, right? I see it vehicles also. So sometimes you will place that sticker, right? This is petrol or diesel. But after placing that kind of stickers also, they will do things. If you are don't know, all the persons who are working in petrol pumps, they are no idea. They will read the English language or something like that, right? So we have to intimate them. This is a petrol vehicle or diesel vehicle. You have to refill the petrol or diesel, something like that, right? So the petrol IC vehicle also the same issue is there. The same problem will be there in electric vehicle. So to avoid that, see the pins, see the port. See the port differences, the AC port differences and DC. See the orange one and green one. Right? Difference will be there. If you are trying to connect with your AC source with the DC source, means no. But last one, see the last model? See the last model in AC and DC? Same, right? That is advanced vehicle, so you have to be careful. Which side you are connecting? The onboard side or the other side? The DC charging side or the AC charging side? That is very important. You have to be very careful in higher end models. But lower end there will be difference. No issue. There will be difference because you are using a maximum and mostly our household source only. Same 222 to 40 volt range AC current, right? So there is no issue with that. But advanced things there will be a big issue. And come to the latest technology that is called battery swapping technology. Battery swapping technology, right? Battery swap technology. Swap, what is the meaning? This for that, right? This for that. So what will happen means like how we are replacing the fuel with IC vehicles, kind of things, right? So we are riding our battery pack till the range reaches to almost less than 10% or some right? So it's going to exhaust very soon, kind of things. So what you will do, you will reach one nearby battery swap station and simply you can disconnect your battery and you can replace your battery with the provision. Empty racks will be there. In the battery swap station, empty racks will be there. So you have to place your own vehicle's battery and you have to take one battery from there, right? That is 100% completely charged. And you have to take that one and you have to replace that one and you can continue your travel, things, everything, right? Without affecting anything, right? You are not spending that much time to replace. Almost it will take 3 to 4 minutes only. For the easy things and all, that's why we are using Anderson connector, right? Anderson type of connector. We can't change the terminals. That is the major advantage of Anderson connector. Right? We can't connect the alternative terminals. But you have made a mistake during the basic wiring things and soldering time means no, that's okay, that's your fault only. That's not Anderson connector fault. So you have to be careful. Whenever you are making cable connection to the Anderson connection, you are connecting the phase wires to the plus symbol and ground common is and negative symbol. That is your thing, right? So, but if you are making the connections very correctly, then there will be no issue. Simply, you can disconnect the Anderson connector and we can place our battery to the side, or we will take one more battery and we will connect and we can continue our travel, right? without spending much more time for the recharge, for the charging and everything, right? But the issue is, in India, there is no universal shape of battery pack. That is the thing. There is no universal system. But some of the things there will be, right? So in India, see the rules, a lot of rules are there, but for tire. For scooters means either you have to use 10 inch or 12 inch. Your hub motor or your rim size should be in 10 inch or 12 inch. Only two options. That is condition. And see again, electric vehicle motors, hub motors or in-house motor, we can call it in another term, in-house motor. So in-house motors in the range of only 10 inch and 12 inch only. 10 and 12 inch. So suppose if you are going to use the same kind of hub motor or in-house motor for bikes means, then you have to extend, you have to increase your wheel size by adding spokes or alloy things. Alloy extension or spoke things. So then you have to increase as per things, because bike tire size that is 15 inch or 16 inch. 15 inch or 16 inch, that is standard. So there is no such kind of standard for battery pack shape, size, and all. Right. So my vehicle battery pack, see the previous slide we have studied, right? So two-wheeler, mostly two-wheeler scooters, battery pack voltage will be in the range of 48 to 72. So either 48 volt battery pack or 60 volt battery pack or 72 volt battery pack. So minus 48 volt battery pack means if I am going to the battery swap station, if there is anything, everything in the range of 60 and 72 volt, then how can I use them? That is the issue, right? And one more thing is that if our battery performance is not well means, simply we will do one thing. What we will do? We will replace our battery, the poor one, to the battery swapping station, and we will take the better one, and next time we will not see the battery station again. We will not go to the same battery station again. That is the basic attitude, right? So the persons are there like that. So if it's 0%, it's already dead battery. Means what they will simply replace the battery pack with the battery swap station, and they will take one good performing battery pack from the swapping station, and they will place it in the vehicle, and they will go. And next time they will not come to the battery swap station. Right? So this is the issue. So we have to calculate and we have to do all the things. Uniform size, uniform range, and we have to find one formula for that. Right? So if my battery, that is performance, that's performance around 80%, right? My battery pack, my own vehicle's battery pack, its performance, current performance range is 80%. And the battery pack in the battery swap station, that is 100% efficient. That is 100% efficient means, anyway, I am going to continue my travel, so I have to swap my battery. Right? There is no option. I can't find, right? My battery efficiency is 80% means I can't find the same range of battery swap, and that is 100% charged also. So I have to choose the one, whichever it is, right? That is 100% efficient battery pack means, then I have to pay for that extra 20% performance, right? I have to pay. Sir, your battery pack efficiency is 80%. Your battery health condition is 80% good. But you are taking 100% good health battery pack. So for this 20% efficient thing, you have to pay this much cost. So we have to create one ecosystem for that. You have to create one system, one development thing for that particular thing. Immediately, once I am taking the battery pack, I am placing my battery pack, it has to calculate within minutes. Within 1 minute or 2 minutes, it has to calculate. Sir, this is the thing, and you have to pay. And if it stores the value, means suppose for the extra 20%, I have to pay some 1,500, 2,000 rupees means, then there also one more issue is there. I don't know if I am having the 1,500 or 2,000 rupees immediately at that point of time. I don't know. So then you have to create one more system for that also. You have to create some kind of credit card systems and all. sir, you are taking this much battery efficient and this much is your battery efficiency and you have to pay this much of amount within this time. That is next day or within 2 days or within 7 days or within 15 days, something like that. So we have to create one system for that. Then only battery swapping system will be a success thing in India, right? So in Bangalore, Honda developed a lot of battery swapping stations, almost all the metro stations. Almost nearby all the metro stations in Bangalore, there will be one battery swap station and it is set up by Honda, right? And it's suitable for only Honda vehicles. Only Honda vehicles. No additional connector, they will use one specialized connector and simply you can disconnect the battery pack from your Honda company vehicle and you can take one battery pack and you can connect it and you can continue your travel. And recently in Chennai also, here Chennai Central Railway Station, they opened battery swapping station. But that is for 2-wheeler. For 4-wheeler, we have to establish and we have to create one system, one common system, one standard. There is no standard size for battery pack. There is no standard limit for battery packs. Right? There is no standard shape for battery pack. And we have to standardize each and everything and we have to calculate that. And we have to calculate that and we have to charge for that, right? So suppose if I'm swapping the battery with 100% and 100%. I'm giving 100% battery pack with my vehicle and 100% efficient battery from swapping stations, then that's fine, there is no issue. But I have to pay for this charging, right? The charging current consumption. The charging current consumption I have to pay. That how much I have to pay. You have to calculate it and you have to implement it and I have to scan or pay or I can, if I'm having only cash means then you have to get these much of things. You have to solve this much of things. Then only battery swapping stations will be in use in India and for all the models, right? You have to standardize each and everything. There is no standard guidelines from government of India till now for electric vehicles, production, manufacturing and all. Right? They are limiting the size of tires only, simply. That is 10 inch and 12 inch kind of things. Right? For scooters, 10 inch, 12 inch. For bike, then you have to adjust that more 3 inch or 4 inches by using spoke extension or alloy extension, something like that, right? So other than that, nothing. So that is the guidelines for tire industries. If I am going to start a tire industry or tire manufacturing company in India means, then I have to produce the tires in that particular range. It's a radial type of tire, or what kind of tire I am going to use, and what is the almost size of the tire, right? That is 12 inch, 10 inch, or 15 inch, 16 inch. That is fixed. I can't manufacture. If I am going to start one electric vehicle industry in India means, then I am just fixing 9 inch. 9 inch rim size, right? Electric vehicle motor or motor size, that is 9 inch means then I can't find any tires in India. Because there is a standard. They have to manufacture the size of the tire, that is 10 inch, 12 inch, 15 inch, 16 inch, something like that, right? So the other guidelines, no, nothing from government of India. Till now in India, ATAL only framing the guidelines. Right, it's not a government body directly, but it's an autonomous body. It is an autonomous body functioning under the government of India. Automotive Research Association of India, that is headquartered in Pune. Right? And they are functioning under 2 type of ministries. One is Ministry of Road Transport and Highways, that is motor vehicle rules related things, and the other thing is Ministry of Heavy Industries. Right, so you have to get the approved or permission from AICTE for each and everything, single component and single small component also. For a screw, for a bolt nut, and for a tire, for swing arm, for whatever it is, suspension system, whatever you are using, you have to get approved from the AICTE. Right, that's why. But for I think 10 to 12 years back, a lot of industries are there. Small scale shops, lot of shops will be there in and around near Chromepet area. right? What they will do means they will convert the petrol vehicles into EV, simply they do, but they are unorganized. They don't know about the capacity, they don't know about the things, and they don't know even to understand the basic concepts of electronics and electrical components. Right? Lot of the mechanics are there, right? What is the issue with the electric vehicle industry done in India? In India, till now, we are suggesting if any component is failure means the only solution, the only thing is there is no service. Only thing is replacement. What is the solution? Replacement. Sir, my indicator is not working, sir. Sir, you have to replace the 12 volt power supply component. What it is? That is DC to DC converter, sir. How much it is cost? It's cost around 650, sir. Good quality 650. Right? Good quality 650, sir. Sir, my vehicle is it's not releasing the parking mode and things. Frequently, my vehicle automatically entered into the parking mode things, sir. But then controller problem. Then what I can do, sir? You can replace your controller, sir. Normal thing 3,500, sir. If you are going for a company or some brand means that is 6,000, sir. Right? Simply replacement. We are doing reverse engineering, right? There is one line. One line will be there in your textbooks. An engineer's job is to invent. An engineer's job is to invent. We have to develop at least something. They are not asking for innovation. They are just asking for invention. They are just asking for invention. A small development. A small development, right? But what we are doing for our final year project also, we will approach one of the shop, right? I'll pay, give me one project. I'm going to my college and I'm going to submit that project as my project. See, that shop already sold the same kind of project for a number of students. Right? So we are not ready to at least to try to create something, right? So reverse engineering. What does reverse engineering means? We will wait in queue to buy the first product. If anyone is releasing the one product means we'll wait in queue and we'll get first product and come and dismantle each and everything, and we have to study the things and then manufacturing. Reverse engineering. Right? So again similar kind of things. Lot of things will be there. Right? Good. So next thing is we are suggesting only replacement. If any component fails, then only solution is replacement. Why? Because the conventional mechanics don't know how to use the multimeter. How to check diode in forward bias or reverse bias, right? How to check resistors, how to check varistors, which one is varistor, which one is capacitor, which one is diode, and which one is Zener diode. They don't know, right? A Zener diode with 5 volt capacity costs only 2 rupees, right? If you are going to buy in retail means, retail itself it's 2 rupees. Last week also I serviced one controller. Only simple problem. Diode fault. Zener diode fault. Right? So they can't find what is the issue with that particular controller board, control things. You have to invest that much because lot of OEMs, virtual equipment manufacturers will use their technology differently. Someone will fix this is the color code for this one and this is the thing for this one. Right? So in your controller class also I may explain one thing. That is self-study option with one Chinese make controller, right? Self-study option. That is mentioned like 60 volt. So what it means the same controller will operate in both the voltage ranges of either 48 volt or 60 volt. So the self-study options, the voltage selection pins are disconnected means it will operate automatically. By default it will operate and it will think I'm going to connect with the 48 volt battery pack. Right? If we are making the connection, we are starting that with pins, voltage selection pins means then the controller will recognize that we are going to connect with 60 volt battery pack. Right? And today we will assemble one vehicle that we will come to know the opposite thing. If the voltage selection pins are shorted means that is 48 volt. If the voltage selection pins are disconnected means separated means that is 60 volt. So everyone, each and every manufacturer will use their some kind of differences, some kind of things and their own design procedures and all. We can't say, right? Someone will use a single layer PCB and someone will use multi-layer PCB. Single layer PCB means then no issue. The multi-layer PCB means then there is an issue. We can't track the circuit, right? Which one is connecting, which one there, something like that, right? And which layer, first layer what it is, second layer what is the connection, no idea. So we have to get that own basic program, the original program, some idea. If you are going to try to understand that programming things means you have to invest your time and some amount of money. Some time and some amount of money, right? To understand the words. So each and every board for X, I am spending 2 months of time and 50,000 rupees, and for Y again to understand Y company's PCB board again I have to spend 2 months time and 50,000 rupees. Then number of companies are there, right? Hundreds of companies are there. If I am spending like this means till the end of my lifetime, no, I can't do anything. So that is the issue. They should know to use at least multimeters. Some of the components also there, right? We have to think about that. Which component we have to check in board itself, and which one we have to take it out from board, and we have to check that separately. Like that, we have to understand that. So at least the basic concepts of multimeters and we can't use multimeters for all the components, right? All the components, to check all the components we can't say like that. So this one is failed by simply checking in diode mode or continuity mode or resistance mode. We can't say 100% this component is good. No, we can't say. Right? We have to check with the data sheet of that particular component. Who's the manufacturer? What is the limits? And what are the things are there? You have to understand each and everything. So in conventional mechanics, they can't do this kind of things. And at least require basic understanding of electronics, electrical components, and at least to use the multimeters, how to use, how to check resistors, how to use diodes, some things and all, right? In our mobile chargers adapter, one more important component, that is diode only, right? Diode. What is the purpose of diode? What is the purpose of diode? A lot of components will be there. There also transformer will be there, right? Capacitors will be there, diodes will be there, resistors will be there, right? Kind of things will be there. But most important component, that is diode, right? Why? Rectifying. We can use diodes as rectifiers. Good. That's okay. But what is the primary purpose of diodes? Very good. Unidirectional device. Who's that? Good. Unidirectional device. See, always what is current? Current means flow of electrons, right? Movement of electrons. And what is voltage means? It will flow from high potential to low potential. Always. So my mobile battery, it has 30% of SOC. Some kind of voltage means I am connecting with my power source. That is AC household facility means. So it is 220 volt or 240 volt. Within the range of 220 to 240, right? So high potential, I am connecting my low potential mobile battery with the high potential power source. So current will start to flow from power source to my mobile battery. So it's charging. So what will happen if I am connecting my mobile phone with the 20% charge, and if it's reached 40% charge, suddenly the power cut means 0 volt, right? In my household source, 0 volt because power cut. Now it's for low potential. And my mobile battery has some percentage of charge, at least some positive voltage in there. What will happen? Yeah. My mobile charge will go to the power source again automatically. So we have to avoid that. So it should allow the current in only one direction. That's why we are using diodes. Unidirectional device. It always allows the current from power source to mobile battery. Do not allow any current from mobile battery to power source. That is the thing, right? But some kind of diodes are there, right? 10 minutes. I think 10 minutes I mentioned one thing, Zener diode. It will allow the current in both directions. That is called bidirectional converters, right? Bidirectional. It will allow the current to flow both the directions, but with the limit. What is the limit? If you are going to buy 5 volt Zener diode means it will allow the current after the limit, right? So that is the thing. So we have to understand that kind of things. So again the same thing, we have to be very very careful in our electric vehicle charging system also. So we have to establish one system that is completely unidirectional. So from power supply equipment to vehicle, that is old thing. And now we are going to discuss about one more thing. What it is means, that is V2G, right? The next topic, that is V2G, that is vehicle to grid supply. That is extra power from our produced by our electric vehicle supply equipment. Suppose I am installing one electric vehicle supply equipment that supports that operates based on the solar energy or wind energy. Solar energy or wind energy means I have to supply the extra current stored in my battery pack or something like that to the grid, right? So I have to think, and suppose our solar system failed or something like that means, then I have to take the current from grid to my vehicle battery. So I should establish a system. I should employ a component that is allowed in both the directions, but with condition. Right? So if this condition, you have to allow the current from here to there, and this condition, you have to allow the current from there to here. Right? Both the directions. So you have to think about it. And vehicle to vehicle, again, charge transfer. Vehicle to vehicle, like in our conventional IC vehicles, simply we can do, right? Someone we are seeing on the way, someone will be there, right? Sir, petrol over. So what we will do? Simply we can stop our vehicle. We will tow the vehicle. Either if possible, if we are okay with that, we can tow the vehicle till the petrol pump, right? Or simply we can do one more thing. We will find some containers and water can, all right? So simply take some fuel and again, so ask them to go to the petrol pump and refill it and then go, kind of things. So in electric vehicles you can't tow your vehicle like that. If suppose on the way breakdown or charge over means you can't do the things, right? Because there is limit. There is limit in the sense what will happen in low range of electric two-wheel scooters, that is operates under 30 km/h speed, right? Which doesn't require the certifications, the RTO, number plate and approval, everything, no nothing, right? Driving license also not required. So that is the thing. The vehicle's maximum running speed, what it is? It's less than 30 km/h. And suppose if one conventional vehicle, IC engine, vehicle front is going to help us, right? So he is telling us, sir, I am going to tow you till the charging station or your home. Till then, you can take your vehicle and I will tow you like this. No, we can't transfer petrol from there to here, right? Because it's electric vehicle, that is IC vehicle. The only way is to tow. But towing means its limit we know, that is its forward limit is forward rotation limit, forward moving speed limit, that is 130 km/h. We can't ask our friend, you can ride your vehicle at the maximum speed of 20 km/h or 23 km/h. No, it's not possible. We can't say like that. It means in case if there is any failure in his odometer, what will happen? He also don't know which one is good. Which is the limit for 20 km/h? Which is the limit for 30 km/h? No, nothing. So that 30 km/h maximum speed motor, you are creating that to run most speed, right? That is 40 km. Then more heat energy will be there, and then coil failure will be there. Coil burning will happen. So it's not recommend to recommend strongly. I can't recommend, and no one recommend you to tow the electric vehicle. Suppose it is a breakdown or charge over means no one will recommend for towing purpose, right? Because it's we don't know what is the capacity, what is the maximum capacity, we don't know. Continuously motor running without a battery supply means what will happen is the other things will happen and coil burning will happen, right? So it's a very again rare earth mineral, right? The magnet material, the magnet material. Mostly we are using neodymium type, right? Neodymium magnets. Its Gauss value is very high. Its Gauss value is very high. That's why we are using neodymium type of magnets in electric vehicle rotor. It's a small strips. And nowadays we are doing powder casting things on that. We are importing the material, not a solid, it's a powder in a powder form. And by forcing, the things we are making a solid one from the powder. Right? And what is the issue with magnetic strips? Suppose if any one of the magnetic strip breaks means the motor will not run, right? Because automatically, if you are breaking the magnet means they will automatically start to create the poles. Right? So one single magnet means one north pole, one south pole will be there. Suppose if it's breaking in half means that is half of the side means then what will happen? Two north pole, two south pole will be there. Right? Then you can't move on motor something like that. So no recommendation or nothing for the towing purpose. The only purpose is vehicle to vehicle transfer, another thing. From high capacity battery pack electric vehicle to low capacity electric vehicle battery pack. Again, simple things, right? Transferring the energy stored in that particular battery pack to this vehicle's battery pack. That is the only solution. Otherwise, if you are trying to tow your electric vehicle, there is no option, sir. There is no option for vehicle to vehicle or to reach the charging station. I have to do. Only one option is there. That is towing option. The other option is there, not available or it's not possible things and what you have to do means you have to disconnect all the connections from motor. Right? So all the connections, you have to disconnect all the connections because we don't know. Suppose if we are towing the electric vehicle at the highest speed 40 km per hour, 50 km per hour means it will take more energy. And the small components which operates under 5 volt or 3.3 volt in controller board will fail. So then we have to replace our controller boards. We have to replace our controller board, that is controller. Nothing with that the controller shell and things and that, right? So we have to, controller board problem is then we have to replace the controller itself. Right? So that is the thing. I told you already, motor will communicate only with the controller, right? There is no connection between any other components and motor. Motor will completely communicate with only controller, right? The brain of EV, electric vehicles brain, right? So only controller. So you have to disconnect all the things to controller to motor. All the cables, particularly 8 cables will be there, right? 3 phase wires UVW and 3 Hall sensor wires for particular phase. For one phase, 1 Hall sensor will be there because there is no separate starting motor. So we have to intimate the controller which phase we have to energize initially to start the DC motor. To start the motor, which phase we have to energize initially, which two phase. So that feedback communicated between motor's Hall sensor to controller. Right? So you have to disconnect all the things, all the connections between motor and controller, then you can tow your vehicle. But that is for unsafe condition only. Towing at maximum speed means it is a major problem. Definitely. Right? As I said, stator coil or rotor magnet will burn. Right? So we can't do that kind of things. and more advanced technologies, charging infrastructure is also there. And I think you might have heard the things, right? In France, 1.5 months before news will be there, right? One news. They are constructing roads which is supporting electric vehicles charging in movement. That is dynamic charging. Dynamic charging, right? Contactless charging based on the concept of induction, right? Based on the concept of induction, the same concept. In most of the major hotels, there will be a scanner, right? To scan your vehicles. What is there inside of your vehicle? What is the things and all? They will scan without touching your vehicle, right? Kind of things. So kind of things, contactless charging also there, right? In parking station, we will place one charging plate, and the same location, same space, same size. We will place another opposite counterpart in our bottom of our vehicle, right? Then we are parking our vehicle like that, means there is no physical connection, but through induction, charging will be happen, right? Charging will be happen. That is contactless charging. And then the things in France and Europe, always Europe, right? Always Europe will do something new to the things for electric vehicles, and particularly contactless charging, that is dynamic charging. So particularly they will lay one lane in highways that is dedicated to electric vehicles. That is dedicated to electric vehicles. So under the road surface, they will place all the things, the inductive plates. The inductive plates, they will place the inductive plates, and while your electric vehicle moving on, that means through induction, your vehicle gets charged in dynamic, right? Without static position, no need to stop our vehicle for charging purpose and all. While in travel, you will get charged, right? By using those kind of technologies, that is things, and dedicated lanes also there. And India also they are proposing something like that, right? For particularly the things. And the other one is, that is pantograph technology. What does the pantograph technology means? The same technology which we are using for number of years for electric trains. So one side pole will be there, and the extended arm will be there, and our trains will touch the line, right? High voltage line. So it will get charged automatically. So kind of things, pantograph. Right? Again, in buses and other electric vehicles, so we will place the same component, and we will post one side post and extend the arm, and it touch, and it will get charged while in movement itself, in dynamic itself. So these are the things, charging infrastructure, right? So these are the technologies. Excellent. But the best one is whatever it is, it's pantograph or highway dedicated lanes for electric vehicle dynamic charging and things and all. But it's better for battery swapping technologies and all. But for that we have to standardize the size of the battery pack, shape, and we have to develop the infrastructure for by using AI or something, whatever it is, right? To calculate how much we have to pay for the charging things, and to calculate how much we have to pay for the extra efficient, for using the extra efficient battery pack from the swapping station. Or sometimes we don't know, right? Sometimes our battery is 100% efficient, and the battery which we are going to replace with the swap station will be 80% efficient. So that time they have to pay the remaining 20% cost to us, right? The extra cost to us, right? So for the 20% efficient battery and all. So we have to establish this kind of things and communication and all. So we have to fix the price. What is the price? What is the general price? And now how they we don't know. See, my battery pack is 50% charge, so I have to charge the remaining 50%. Right? So I am placing my battery pack with that remaining 50% charge in my battery pack. I can't travel that much of distance. So I need 100%. What I will do? Simply before reaching my battery pack 0% voltage, simply I will replace my battery pack with this swapping station, and I will take one more battery pack from that, right? So I am just consuming extra 50%. I am not placing over the 0% charge, right? I am placing the battery pack with 50% charge, I'm taking battery back for 100%. So I have to pay for extra that 50% only. So this kind of things. I can't say always 50%, 45%, 40%, 30%, 20% will be there, right? Something like that. So we have to do all the process, all the things carefully, and we have to create one mechanism, one system for the things for collection of payments, how we are going to collect the payment for charging and all, that extra efficient battery supply and so things we have to plan, right? That is the thing we have to plan. So everything within minutes means no, there is no possibility. That's why we have to create one more mechanism. So after reaching your home, someone will be there, right? I have to pay 2,000. Right now I am having only 1,000. The remaining 1,000, once I have reached my home, I will pay. Something like that. So post bill concept also you have to implement that. Right? So you see one by one. I am explaining all the things. Just we'll see one by one. This is the supply change station. See the battery swapping station. Battery swapping station. Right? Just replacing with the battery packs. So, the kind of same thing happening with our MTC transport electric vehicles. They will do the same thing. Right? In MTC depots, there is a separate dedicated charging station like this. What they will do means, once up and down, the vehicle again reaches the station means what they will do? They will take out the battery and they will replace with the other one battery, the fully charged battery. So a swapping session with the closed area, someone implementing for their office, that is okay, that is fine. Right? If in my company, I am establishing my own battery pack swapping station for my company employees means that is fine, because they are working in the same area and I can connect or I can charge or I can cut their salary according to the usage of that battery power swapping station. But here the issue is the third person to third person. Someone, as a third person, I will invest one battery pack station nearby somewhere, nearby my home or somewhere, the high requirement area. By doing all the case studies, right? How many vehicles are there in already surrounding area electric vehicles? And what are the majority category? These 48 volt vehicles are 60 volt battery pack vehicles or 72 volt battery packs. You have to study each and every concept, every aspect. Then only you have to invest in charging infrastructure, because it's high in capital investment. It's a high in capital investment. You have to be very, very careful with that. You have to study before investing in charging infrastructure. How many vehicles in your surrounding, and what are the requirements, what are the limitations, and how frequently they are going to use. See, simply they are 4 to 5 days once they receive is no, there is no issue. There is no use of establishing the charging station over there. Frequent use, every day or 2 days once at least. They will come and they will replace their battery and they are going to miss. That is okay, fine. And you have to study everything and then only you can proceed further, right? For establishing battery power charging stations. See the advantages of battery swapping. They are mentioning about the challenges, right? So the first one, EV recharging is completed in minutes. Advantages, that is the advantage, right? Within minutes, 2 minutes, just disconnecting my battery pack with the vehicle. Yeah, 2 minutes. And I am just taking one more battery pack from this swapping station. That is very good, right? And see the next one, first barrier. First barrier for battery pack swapping station. First barrier, lack of standardization among EV batteries. That is the first disadvantage. There is no particular shape, particular range, nothing. Right? So that is the biggest issue. And see the second one, unsuitable battery pack design. Unsuitable battery pack design. If I am placing the battery pack in battery swap station, that is 24 Ah capacity, but the customer his requirement is 30 Ah or 40 Ah or 42 Ah, then what will happen? What will happen? There is no use, right? For his requirement, he needs again 40 or 42 AH or 50 AH or 60 AH backpacking. That not enough. We don't know. Right? First day I have to travel 100 kilometers. Second day I have to travel to the 200 kilometers. Then what I will do? I have to take too much capacity, 2 types of capacity of battery pack, right? If it's not available with the battery substations, then that is also issue. Then that is also issue. Right? Today I am having one work with within the limit of 100 kilometers, then that's fine, okay. That's battery pack, okay. But the very next day, I have to travel for 200 kilometers, then I have to choose the more capacity, the much more capacity of battery packs. If it's not available in the swapping station, then that's also issue. But in conventional ABS, that's not an issue. If I'm going to travel the another 400 kilometers also, that's not an issue. Because there will be a lot of petrol pumps on the way. So the fuel empties means again and again we can refill it and we can travel. We can travel continuously without any hazards or problems, right? But with electric vehicles, limitations are there. We have to think in that particular area there is battery pack power station, swapping station is there or not, or charging facilities available or not, something like that. We have to confirm. Then only we have to take our electric vehicle to that particular place. That is the issue. Right? Okay, you can go and enjoy your tea break. Then we will discuss further.
We will now have a tea break for 10 minutes. Kindly assemble at 3:25.
At 20 minutes maximum. We have covered all the things, right? Without moving slides, we have covered everything. But now let's see the things, right? So the issues with battery swapping station, two major things, right? One is standardization, and second one is the capacity things and all, right? So suppose if I am required much more capacity of battery packs means then it will be a issue. They will consider the majority, right? One size will not fit for all, right? One size will not fit for all. So we things with the majority of things. So most of the vehicles in the range of 48 volt battery pack or 60 volt battery pack or 60 volt battery pack, something like that, right? So we have to decide in that way. So we have to study all the case studies. So what are the requirements? How many vehicles are there in that particular local area? Something like that, right? So this is the thing. And in highways and for long distance travels, we think that is dynamic charging will be a better option. The contactless charging, right? So we have dedicated a separate lane for electric vehicle charging. Like in France, right? They did 2 months back. I mentioned earlier, right? So 2 months back in France, they dedicated a separate lane for electric vehicle contactless charging. That is dynamic charging, right? They are laying the things and all, the inductive plate undercover or something to the surface of the road, right? So there, right? So next thing, see the charging standards and the interoperability. See the ports, charging ports, different kind of types, right? We have seen that one. See the public charging points by power rating. Maximum in the range of which one? 11 to 22 kilowatt. 11 to 22 kilowatts. So lot of two-wheelers comparatively heavy vehicles, four-wheelers, but lot of vehicles in India they are using low range of vehicles, that is scooters, three-wheelers, right? Kind of things. See the EV classification, right? First one is home based, right? Home based, that is AC charger. So for four-wheelers, four-wheeler is not an issue. You can use the same voltage, that is 220 or 240 voltage. Between the operating range of 222 to 240 voltage. But for four-wheelers, you have to buy one separate system for AC charging, at least somewhat quicker than the basic chargers. That is charging standard charger, that is 1.0, right? It will take 4 to 8 hours to completely charge your battery pack. From 0% to 100% SOC to 100% SOC, it will take almost 4 to 8 hours, right? So normal charger, it's a standard charger, right? Then fast charger, AC fast charger. AC fast charger means it's a separate equipment, so it will boost up your input voltage, so it will reduce the charging time. That is between 2 to 4 hours. That is between 2 to 4 hours. And fast charging, that is DC charger, right? fast charging, electric vehicle power supply equipment kind of things, right? Electric vehicle charging infrastructure, that equipment, that particular equipment, right? So it operates under high voltage range, that is around 600 volt and 1000 volts, 1200, 11,000 volts also sometimes, right? So based upon the grid things and all, right? So DC fast charging, so it will say maximum half an hour. Maximum half an hour. So that is the issue. And see the thing. So now you can understand the things, right? The difference between off-board charger and on-board charger. Off-board charger and on-board charger. For if you are connecting your vehicle with AC power supply things and means, so you require one thing, one separate dedicated thing, that is on-board charger. Well, to convert AC into DC and to filter the noises and all, right? So filter all the things, and again we have to convert that DC into again AC, and that we have to convert that into high frequency AC current, then again AC to DC, and finally again one more filter and BMS battery pack. So these are the things are there in the onboard charger thing. So we can't take the onboard charger, this kind of components along with our external things, right? That is off-board thing part. So that's why permanently we are fixing that one as an onboard charger inside of our vehicle. Inside of our vehicle, right? So we can connect with our vehicle with the AC systems and DC charging equipment also. So if you are going to connect your vehicle with the DC power charger, that is supercharger or fast charger means, so there is no requirement for onboard charger. That's right, because everything is there in the power supply equipment. All the process, that AC to DC, the low frequency to high frequency, filtering, everything will be happen inside of that power supply equipment itself. So there is no requirement for separate onboard charger or this kind of things in our vehicle separately. So that's why from electric vehicle power supply equipment we are connecting directly to the BMS and battery pack for charging, right? So these are the differences. Right? These are government initiatives, and see the things. Electric vehicle power supply equipment and charging ports, again kind of charging ports, which one is external and which one is own charging network kind of things, right? So one is one kind of network, so for my vehicle. So other two things I can provide for some for rent or to charge some amount for the charging things and all, right? So these are the three-wheeler charging stations, public charging stations. Some of you refer, right? Some of you asked during the break time, sir, there is any possibility or rules or guidelines? No, there is no separate guidelines or rules for or separate license for to establish the charging infrastructures, right? But you have to follow the other standard procedures. If you are going to, if you are planning to start one power battery pack swapping station or charging station means there is no separate license, separate guidance for this kind of thing, but you have to follow the other standard safety guidelines, rules and certifications, everything. Right. So again, you have to get the permission from the authorities also, right? For the power supply things and all. So they only will update you. So these are the areas. These are the areas. This particular area you can get the 600 volts, 600 volts high power grid supply. These are the areas with 11,000 volts power supply. So these are the areas. So they will decide that. These are the areas you can establish your charging infrastructure. So other areas we won't allow, sir. So this is the area. This is a high risk area. So here we can't allow the electronics, right? It's a kind of explosive things and all will happen. So it's everything involved, again fire, things are involved, right? So that's why they will give me guidelines. Right, in Tamil Nadu itself you can approach the TAN transfer, right? So TAN transfer, they will update you. So these are the areas available with the high voltage range of grid power lights or things and all, right? So you have to care about that. Then you can start how many charging ports you are going to install in your charging station, or how many supply equipments required for that particular area. Suppose most of the vehicles are EV vehicles means then you can. Right? Then you can start one power station, then second charging station, third charging station. Each charging station with 3 ports. Right? These are the ports. Right? All the 3 ports are similar, or this one is for this one is for the kind of mobile charger. In a single cable, they will give some 3 to 4 types of charging port. Right? So something like that. Right? So everything. These are the demands and everything. Location planning and land allotment, everything you have to get from the authorities. That is, there is separate authorities for each and every step. So what are the dedicated locations? You have to find out the dedicated locations. These are the locations. Because you have to install your charging stations nearby main roads or high requirement areas. You have to find out each and every. That's the major issue. So nearby bus stand or nearby petrol pump, or if possible with the petrol pump, or if possible with the petrol pump itself, right? So one side fuel pump will be there, and one side EV charger will be there. It's kind of things, right? So that is the think about it. So accessibility, that is the first thing. Accessibility. It is easy to accessible or not? That is the question, right? It's very easy to reach that particular charging station, or not. It's a highly crowded area, or it's a very free area, or it's a feasible one, something like that, right? So you have to think about it in the first particular way, that is accessibility. If I'm going to establish one charging station over here, means it's okay for the customers, for the electric vehicle things on, right? And next, second one, what is the utilization level? They will use regularly, daily, or twice a week, or thrice a week. So what is the pattern? How they are using them, right? Then some of us will take our bike to petrol pump each and every day, right? And someone will have that particular kind of character. What they will do means they will do, refuel their bike by using some small amount for each travel itself. Within a day, multiple times they will reach the petrol pump, right? First 50 rupees, then 50 rupees, then, sir, one more customer is calling me for the service and all. So it is around again 20 kilometers far from here. So again I have to go to the fuel pump station, again 100 rupees, something like that, right? And someone will plan. Each and every time he uses the fuel pump means what I do? Only one diesel, full, tank fill. Till that time. That is the only condition. Every time, each and every time he reaches the petrol pump, only one condition. Till that time. That's the thing. So you have to study about the mindset, the things of customers. They will use regularly or daily, or you have to know the pattern. Otherwise, everyone, each and everyone will be there in one point of time. That is within 1 hour. Within 1 hour, 10 to 15 persons will come. Sir, charging port is available or not? Available or not? It's already full. It's already full. They will get, right? And the remaining 23 hours of that particular day will be empty only. There will be no big. So you have to know the pattern. They will come by during the peak hours. They are coming by the evening time and night time. What are the patterns? So you have to speak that pattern. If regular customers meet, you have to plan it. Sir, you have to come by this time, right? In some places you will get the same result, right? If you are visiting a particular place regularly, means they will tell exactly, right? And today also the thing happened for me. From the government ration shop, they have left me, sir, you have to come by every Friday, sir. Every month they will come by second Friday or third Friday, something like that. That is after 11 a.m. sir, will be free. Something like that, right? So then you have to update it. So this time, charging station will be free, something. Customer should know that. Otherwise, it's an issue. And that's also is okay for, you have to get information, confirmation from the customer, if that particular time period is okay for him or not, something like that, right? And then you have to work with the cost. You have to work with the cost. What will be the cost? You have to pay for the grid itself, right? Right? You have to pay for the grid. How much we are using, you have to pay regularly. And what is the equipment cost? I already mentioned like that. It's a heavy. It's a heavy one, right? Heavy capital investment. So we have to be ready for it. You have to think in each and every aspect. Site selection. See the thing. See the thing. See the patterns. So what are the area? Planning into cells. That is 1 square kilometer, 1 cell. What is the meaning? 1 square kilometer, 1 cell. And see the customers in the second image. Second image. We have to connect that area. This area, this 1 square kilometer, 4 electric vehicles is there. And this 1 square kilometer, 2 electric vehicles is there. Something like that, right? And we have to relate that. And see the thing. And see the second thing. The first point or second point is very easy. Right? See the lines. First one line and second one line. See what are the possibilities? How many dots are there? See the dots. Orange colored dots. The potential areas to establish electric vehicle charging stations. Right? So see the areas. How they are covering for a particular local things. See the locations. They are covering all the corners, right? In and around all the areas. So everyone will know. Here is the station nearby our home or nearby our office or something like that. We have to plan that in that way, in a particular way. Right? Just establishing power supply equipments in summer it's not that much. It's very easy to place all the power supply equipments nearby in a single line. No, it's not good. It's not advisable, right? So this is the better way. And see the other things. How to arrange your infrastructure things. Suppose if you have very limited area. If you have very limited area means how you have to plan to accommodate more 2-wheelers or 4-wheelers. Right? See the guidelines. Distance, how much distance will be there between the one vehicle charging area to the other one. Right? So these are the things. See the next one. See the nearby railway station. What do you do? If some actually most of the people will go to reach the office by using public transport, own transport, something like that means they will park their vehicles nearby railway station or nearby bus stand. Ideally, just ideally, for that 8 hours or 6 hours or 4 hours, 2 hours, something like that, right? So that time they are using that time. So you have to establish many charging infrastructures near the railway stations or the parking areas. So that parking time, that idling time they will use for. See the public area. See the next one. Some shopping mall, something like that means there also lot of things are there. Nearby movie parks, because they have to spend 2 hours time there. So within that time period, their vehicle will get charged. Nearby supermarkets, nearby shopping malls, nearby movie parks, or nearby railway stations, bus stands, something like that, right? So that time, or nearby office parking, or exactly office parking. So they will, if somebody will go by their own transport, right? By their own transport to reach the office, right? They use their own vehicle, 2-wheeler or 4-wheeler, something like that means. If we are going to establish one charging infrastructure in our company, parking area, that will be also fine. So they will change and they will use it regularly, right? That is the plan. That is the plan. So otherwise, this is a very important thing, right? You should not establish the charging infrastructures nearby areas where people usually travel on the way, because they will not spend that much of time. They will not spend that much of time. Right? If I am traveling from Chennai to Vellore means, then I have to travel continuously. There is no time to spend 1 hour or 1.5 hours in between somewhere to get charge my vehicle, right? So if I am going to charge my vehicle means that time I will plan an alternate plan for that half an hour or 1 hour. Right? Whether I have to take lunch or breakfast or dinner, something like that. During that time, I will plan to go any shopping mall or somewhere, because I don't know where I have to wait. Where I have to wait. Simply I can't wait for 1 hour. Right? So that time I'll usually plan to do the other activities, the shopping things or something like that. Right? So in the meantime, my vehicle will get charged. That's fine. Simply sitting in some kind of chair for 1 hour or 2 hours and I am paying for the charging fee and all this, no, it's not good. Right? But for that, what I will do, if the movie ticket costs 100 rupees, then I will pay. Then I will pay. Nearby one charging station is there, I will park my vehicle, I will put my vehicle in charging position, then I will go to the movie. Then after some time, there is no condition, right? I have to watch the movie fully, 2 hours or 2.5 hours, something like that. No. So just for that 1 hour, I will go for that, and after 1 hour, I will come out and take my vehicle, then I will start my travel. Something like that, right? So that is the thing. So people, where they will get some kind of rest or they will spend some time, that is the proper location, that is the best location. If charging station is nearby their home means they will spend, because night time they will be there in the home, right? So establishing nearby their home on the charging station means they will use it. And other things are all we have to think about. Nearby shopping area, nearby fuel pump or nearby highly crowded areas. That is the best way. Right? Types of charging wheels and toll itself. See the charging port, another kind. Right? Home based way. That is sufficient for two-wheeler, right? 222 to 40 volt, that is okay. That is fine for you. See the base. Simple. The existing meter will support for a two-wheeler. Existing meter, home based connection power supply things, and that is sufficient for two-wheeler. And see the next one, it requires one transformer because for high voltage things. For high frequency AC, then we have to convert the high frequency AC into DC. Then we have to establish one new meter, because the old meter, already existing meter will not support that much of high voltage. Right? Then we have to place one new meter to record how much they are consuming, how much we are consuming, kind of things. Then car. And see the next one, solar panels. Solar panels, again battery. We use the batteries for storage energy, right? Because in daytime only we can produce the solar electricity. In night time we have to use it, right? So for that we have to store the energy. In daytime produce the energy in some kind of storage things, especially in battery. And from that battery again we have to use one inverter, right? Because to convert DC into AC. Battery is DC, right? Direct current. And we have to convert that current into again AC, one inverter, and then again plug point, then we can charge our cars through the way of onboard charger. Don't forget that, right? If I am giving AC input means that is the proper port is onboard charger port, right? See the next one. Again, high transmission connections, right? Heavy, 11,000, 12,000 kilovolts, something like that will be there. So 11 kV or 12 kV, something like that. And again, distribution transformer, and again one new meter, then submeter, and then submeter to the vehicles. Charging system. See the thing. Metric connection. Usually, if I am having the required amount of energy through solar panel means that's okay, that's fine. But it's not meeting out the requirement means then I have to take the additional support from grid. Or if I am producing the over current by using the solar panel grid, then I have to supply that extra current to the grid itself. So two-way, bi-directional connection should be made, right? So this is the thing. And see the next one, that is swapping and all. EV charging loading in California. So even in India also, they are taking the reports from California because there is no established system in till now in India, right? That is the thing. And see the same. See the charging. What are the agencies? First, private EV user apply for separate EV connection with the TOD meter. Additional meter, separate meter for EV charging and all. And next one, then programmable EV chargers because we have to enable the functions. How much time it has to charge and the cutoff things and all everything, right? Cutoff and automatic on conditions, everything we have to enable the things. And next again we have to compare with the TOD applications conditions and all, right? That is the thing. See, again integrating grid. Our charging station integrating with the grid. So we are taking the supply and over supply means we are producing over current means then we have to supply to the grid. Again bi-directional things and all. Right? I think that's it. Readouts. This is the integration of things, right? CPOs means charging points. CPOs means charging points. That's it. Readouts. Nothing. I have to think out.